Okay, accelerated 7th grade math. This is going to be your item number 15. And we are going to be talking about properties of real numbers. If you have written your objective and done your vocabulary, then you're about ready to move on. If you have not, then you need to stop and go back and do those. Your objectives read something along the lines of, I can use properties to simplify expressions, or something along those lines. Make sure that you uphold your objective from Canvas, and again, you will know what you know once you have taken your Canvas quiz and passed it at 100%. So basically what we're going to go over today is properties that you probably know exist, you just didn't know that they had a name. Okay, so we're going to go over the 1, 2, 3, 4, 5, 6, 7 properties that you're actually going to be using on your properties project tomorrow. So if I were you and I was taking good notes, I would be using the properties the information from these notes to do your properties project tomorrow. Hint, hint. So the first property is going to be the commutative property. Okay, and the internet will say that this is the property that has to do with moving stuff around, but that's not what I want you to think about it as. Yes, it is about moving stuff around, but that's not the official definition. The official definition is going to say that we add or multiply in any order, and it does not affect the solution, or doesn't affect the solution. Okay, and I'm going to show you that numerically, and then I'm going to show it to you algebraically. When I ask for an example in that project, I'm going to ask for a numeric example. So if we're looking at, we have both addition and multiplication, right? So if I said I have 6 plus 4, well, that's going to be equal to 10. But I could also say that 4 plus 6 is equal to 10. So no matter what way I multiply or I add things together, it's going to equal the same answer. Same thing with multiplication. 4 times 3 is 12. But if I flip them around and I say 3 times 4, it's also going to be equal to 12. So algebraically, so I can write it with any variable, and I can plug in any number, right? So algebraically, I can say that A plus B is equal to B plus A for addition. Or for multiplication, I might say A times B is equal to B times A. So I could plug any numbers A and B in there, and those would still stay true. Okay? And what I want to tell you is that this is going to be the one called ordering. So if you are going to associate a word with commutative property, it's going to be ordering. So in a community, things, or when you commute, there has to be an order, right? So when we commute on the traffic, it has to be in lanes, so everything's in order. That's kind of how you can remember that, or find somewhere other way to remember it. But in commutative properties, we can add or to multiply in any order, and it won't affect our solution. Okay. So the second property we're going to talk about is the associative property. And the associative property is going to have to do a lot with parentheses. Okay, it says when adding or not subtracting, when adding or multiplying changing the grouping or who they associate with, right? Changing the grouping will not affect the solution. or it doesn't matter. Either way you can write that, that's fine. Okay, so let me show you with numbers first, and then I'll show you with algebra what we're talking about. So algebraically, I would say if I have 4 plus 3 plus 6, that's going to equal, well, 6 plus 4 is 3, or is 10 plus 3 is 13, right? Okay, that way I am going to say, well, I grouped it this way. I said 6 plus 3 is 9 plus 4 is 10, or is 13, sorry. Or what if I said 4 plus 3, and then I added 6, so let's try it. 4 plus 3 is 7, plus 6 is still 13. Okay, that's for addition. What if I looked at it for multiplication? Well, I'd say that 5 times, oops, I should have done that in red. 1 times 2 is equal to, well, 5 times 2 is 2 times 5 is 10. But if I said 5 times 1 times 2, what's that going to equal? Well, 5 times 1 is 5 times 2, again, is 10. Okay, and that's going to work if we have just a multiplication in there for anything. And we're going to show it to you algebraically so that you can apply it to any numbers and it will always work. So algebraically, we're going to say if I have A plus B grouped together and I add C, it's going to be the same as saying A plus B plus C. Let's see color, sorry. Okay. Or in multiplication, I can say that A times B times C is equal to A times B times C. Okay, that is how we're going to write that algebraically. So you can go ahead and note that the commutative property is ordering, the associative property is grouping. So you can remember that in order to group things differently, if it is grouped differently and it's addition or multiplication, that is going to mean that it does not affect the solution of the answer. So the associative property, or the way we associate with people or associate in our groups, has to do with the grouping or parentheses, which is why I put this one in parentheses. So associative has to do with grouping, commutative has to do with ordering, or the order in which things appear. I need to flip the page, so you're going to go ahead and pause it if you need a little more time, and if you don't need a little more time, you're going to go ahead and flip the page with me. We're going to talk a little bit about counter examples, which you should have defined. Okay, a counter example means that we're going to prove something with the exact opposite. So if I say all 7th graders are boys, who is a counter example of that? Well, you might be thinking of Angelica, or you might be thinking of Angela, because they are both girls. And girls are not boys, so that proves that all 7th graders are not boys. What if I said that every 7th grader takes Common Core math? Well, all of you in this room who are 7th graders and are not taking Common Core math are all a counter example of those things. Okay, so you're going to prove it wrong. So this is going to be using a counter example, because I kind of want to make sure you understand that. So using counter examples. Because in our quizzes, it's going to say use a counter example to prove, and you're going to have to pick which one shows you the counter example. So I'm going to say, after we've learned those two, I'm going to say the associative property is true for subtraction, which we know is false, so don't think that's true. Works for subtraction. We know that it doesn't work for subtraction, so do not be tricked and think this is true. We're just going to prove this by counter example. So let's try it. Well, let's just plug it in. If we know that when we said that we had that little algebraic expression, well, if it's true, if subtraction, let's put the algebraic expression out there. So what this says is if a minus b minus c is going to be the same as a minus b minus c. Okay, so let's grab some numbers and plug it in. So let's go ahead and say that a is equal to 10, and b is equal to 7, and c is equal to 2. Okay, when we plug those numbers in, we're going to get 10 minus 7 minus 2, which is equal to 10 minus 7 minus 2. Looks nice so far, doesn't it? Well, let's go ahead and say that's 10 minus, well, 7 minus 2 is 5, equals 10 minus 7, which is 3, minus 2. So you should already see, like, uh-oh, looks like something's going to go wrong. Because when I take these two together and I solve them, 10 minus 5 is 5. And that's going to say that's equal to 3 minus 2, which is 1. Are those two equal? They certainly are not. So we put a slash through the equal sign. And we can say that the statement is false. So we just proved that this statement is false by counterexample. So I'm going to put a little cloud over here. So I'm going to say proved by, this is proved, I guess, false, by counterexample. That way you understand how this one was proved false. Okay. Now we have a few more properties to go over. We have 5 more properties to go over, but the next one's probably the longer of those, and then the next are pretty simple. So the next property is the distributive property, which we use the distributive property a lot when we're doing equations and when we're solving for things, and you'll use that later on as we go. The distributive property, you guessed it, means that we're going to distribute things. Okay, so we're going to distribute each of the things on the outside of the parentheses to the inside of the parentheses. So that's going to look like this. In numbers, we're going to say that's 3 times 4 plus 8. Okay, and if we just did this regularly, we could do this first. We'd solve this and we'd say it's 3 times 12. And 3 times 12 is 36. Now remember, we can, Common Core is kind of about solving the same thing in multiple different ways. So let's solve this using the distributive property. I could say, well, I could say that 3 times 4 plus 8 is, okay, well that's 3 times 4, which is 12, plus 3 times 8, which is 24. Okay, let's put it in all the steps. And that's going to equal 36. So they're the same, but we got to them in 2 different ways. Okay, so algebraically what we say is a times b plus c equals a times b plus a times c. So let's look at it, a couple of different things that we could do with that property. Well, if I have 15 times 103, it's not easy to do mental math with that. But what if I use the distributive property and I broke this up into 2 really easily handleable pieces, and then I multiplied it by 15? For instance, when I see 103, I see that that's 15 times 100 plus 3. So then I can break that up using the distributive property, and I can say, oh yeah, that's 15 times 100 plus 15 times 3, and 15 times 100 is 1500, and 15 times 3 is 45, and that I can easily add to be 1545, or 1545. So breaking that larger number up into 2 and then multiplying that number by both the add-ins makes it a little easier to do. Okay, so let's look at another one that we might be helpful with. What if we have 4 times 38? Well, I just have to say that I could do 4 times 30 and 4 times 8, but I also see that that's just 40 minus 2, right? So what if I did 4 times 40 minus 2, which again does equal 38. Then I do 4 times 40 minus 2 times 4. That becomes 160 minus 8, which can then become 152, because that's an easy thing for me to do. Okay, you could have also done it where it was 4 times 38 is equal to 4 times 30 plus 8, which becomes 4 times 30 plus 8 times 4, which becomes 120 plus 32, which becomes 152. Either way, again, you can do it, you can do it either way as long as you get to the same answer. Okay, that's what Common Core is all about, knowing different ways to get to the same answer. Okay, so I have 4 more properties, and they're really simple to go over, but I'm out of paper. So I'm going to flip over to the next side. If you need to flip, that's fine. If you don't, continue your paper. If you need more time, go ahead and pause your video. Otherwise, follow along with me. Okay, so these are the last 4 super simple properties. Again, we're going to include these in our properties project, so make sure you take the notes. We're almost done here. This is the additive inverse. So the additive inverse says when you add 2 opposites, let's go with opposite numbers, you get 0, which you already knew, but this way you have a property that tells you that. So the additive inverse says if I have minus 5 plus 5, or negative 5 plus positive 5, that equals 0, which you already knew, right? That's simple. Okay, what about the multiplicative inverse? Okay, so if we have the multiplicative inverse, the multiplicative inverse is kind of going to be the same as, oops, I spelled that wrong. Inverse is going to be kind of similar to the additive inverse. It's going to say if you multiply a number by its reciprocal, you get 1. Which I'll show you the example and you're going to be like, oh, I already knew that one too. You have 8, which is the number, times 1 over 8, which is the reciprocal, and that's going to equal 1. So you just take that one and the reciprocal becomes that number under 1. So this is the reciprocal. And 8 times 1 over 8 is 1. Obviously, we just cancel those out, cross cancel, that becomes just 1. You probably already knew that. Now you know that it's called the multiplicative inverse. Okay, we have 2 more. We have the additive identity. The additive identity is going to say if you add 0 to any number, it doesn't change. So, simple example. I could say A plus 0 equals A. Or 0 plus A equals A. If I add 0 to any number, it's going to equal A. And last, we have the multiplicative identity. And the multiplicative identity is going to be related to the additive identity. The multiplicative identity is going to say if you multiply any number by 1, it does not change. And you're going to see these examples and you're going to be like, I already knew that, but now you know what the identity or property is called. So 8 times 1 equals 8, or 75 times 1 equals 75. Super easy stuff. So if you are going to take all these notes, you're going to do the homework. You're going to use these notes to finish your properties project the next day. Okay, if you have any questions, go ahead and ask me or email me. Otherwise, good luck.